Hello kiddos. We're going to talk about how to service a motor. This is a motor that I did in a past video that I replaced. I want to go over some of the components of a motor and some of the tools that you may use to service a motor. When you're doing this, you got to be careful. If you've ever worked on a cell phone, you know what I mean. You got to be careful because if you bend it out a shape or something, it may not go back together, or it may not stay together. One of the things you may use is nut drivers. These 5 right here. Color code tells you what size it is. For instance, blue is 3/8, red is 1/4 inch, brown is 7/16, yellow is 5/16, and green is 11/32. Normally on motors it's between 11/32 and the blue, which is 3/8. I used 1/4 inch to break off extra threading when I replace a motor, because it's just simply it's got a hole. And if you notice in a nut driver, if I can get it to where you can see it, there's a well or a shaft, if you may say, inside there. Okay, that allows you to go over long threads. Not extremely long, but a majority of the motors that you have, and when you put a nut on it, there's more than enough inside this well. All right. Here's the motor. Here's the shaft. Underneath this little plate right here, which you can hardly see. If we clean some of it off here, because the oil sometimes leaks out of it. And some of the other tools, for instance, like a ice pick or a scribe-like tool, it's got a little point where you can get into things. I also have this little tiny screwdrivers that you get free from parts houses, because it's got a valve stem core remover that you would use in air conditioning. All right, and then a regular flat head screwdriver. I usually use the ice pick or the scribe to try to get right here. There's a lip right here, and if you see this little indentation, this is a cap. Underneath this cap is the bearing, and you'll find wick where it's coated in oil. That oil in that wick keeps the bearings around here lubricated. You have it on the front side, and you have it on the back side. Alright? To flip it back over, again, it's an old motor that doesn't work anymore. There's a trick. It is difficult to get this little cap off, but we're going to see if we can get the process done.
Eating healthy is complicated and really expensive, but if you find...
Well, this one's been on for a while, so it took a little bit more work to get it off. That means is if this motor was a good motor right here where I had to push it in a lot, I've damaged it. But I have done it before. But the good news is with this little groove, a lot of times you can, when you have it out, which I'll pull it off, when you have it out, you usually can take the screwdriver and feed it back out again. Like so. Okay? Most of the time they're not that difficult to get out, but this one's been in a while, and probably no one's really tried to service it any. And I usually use a rubber mallet, but I don't have it with me at the moment. But in this case, we're not going to try to save it because we don't really need it. This motor is a bad motor. And you've noticed this little stuff here. This is the wick stuff. It's kind of like a grounded up cloth, paperish type material. If you were servicing it, this is where you would put the oil. And the best oil to use is transmission oil. It's designed to take up high speeds and high temperatures. And matter of fact, majority of the oils we use to lubricate motors and devices in this field, we use transmission oil. It's the better oil. It lasts longer. But this is the wick stuff. It's coated with oil. It's nasty. All right. So we're going to remove the wick stuff because we're not going to keep it, and we want to break down the motor a little bit more. Okay. So you can see what's all involved in the motor. If you'll notice, when I clean this out, it's a deep well. It's deeper than it looks. And if we damage this one, it ain't going to hurt nothing. Like I said, it's not good. And we may be able to see the damage of it when we open it up. But I want you to see what a motor looks like on the inside as well. Also, if you notice, it's pretty sealed up. This is an outdoor motor. If you notice, there's no holes or air vents or anything inside this motor. If this was a blower motor, not a fan motor, you would see a lot of holes in it, which allows air to go through it to help cool it off. One of the biggest problems with a motor that you have to contend with is heat. It's the biggest killer of a motor. And so if it can't cool off or prevent it from overheating, it's going to get damaged inside there. And I'll show you what gets damaged when we get inside. And most motors have a nameplate. If you put a new one on it, it's good to take a picture of it, because a lot of times this fades away over time, especially the fan motors out in the weather. The sun, the rain, all damages it. But like I said, I'm cleaning out the wick stuff, okay? And like I said, you have another one on the other side, and it's probably going to be just as difficult, if I had to guess, but I may be wrong. See, it's being stubborn. And most of the time when you get to the motors like this, it's been on there a while, you get to a point that it's time to replace the motor. There we go. It's going. Alright. I wanted you to see the back side as well, so you can see that it has the same wicking. Here's a wick. This side looks a lot better than the other side did. Okay, and again, it's got a deep well as well. Right? It's just wicking material. Don't lose it. Protect it. If you're just servicing it, you do not want to get this out. You don't want to get metal shavings, dirt, or any of this when you're doing it. You want to do this in a clean environment so you don't, because if you get dirt or shavings or anything inside here where this wick is, it could get inside there and where the bearings are. Okay. Alright. We're going to take this motor apart. And to me it looks like it's 3/8, and I was right. Take the blue one. Sometimes it's the newer motors. It's going to be, remember these bolts go all the way through to the other side. And you may have to hold it on both sides of it, just depending on how rusted the threads are. Okay. So we're going to take this whole thing apart. And if you're smart, you'll have something. I always use white rags because it helps you see what you have. So it's easier to see and identify screws and stuff. It just looks better on the white where you can see it. And that's why I use white. And it's reused, right? See how long this nut is, and we keep the parts. And also a magnetic tray, also a good thing to have. Okay. I wouldn't advise doing it inside like I am, but this is where I keep my camera, and I'd rather have it where I can. And I'm just holding the head on the other side with my fingers. Okay. A lot of times you have to take them apart. Matter of fact, the overload protection is built in the winding, so you're not going to be able to replace that. If you ever figure out that your overload is bad, you just have to replace the motor. Now there is some motors that they build that have where you can replace the overload, but these type of motors, nah, you don't have that problem, that excess, that capability. And it's time consuming taking this apart, but when you're servicing it, when you're doing a whole unit, it's included in the price. The faster you do it, the better off you are, and the more experience you get with it, the quicker it is, right? In the newer motors, and if you start off doing it, these motors will be easy to take apart and put together if they service it like they're supposed to every year, right? Yeah, it's just, like I said, it's time consuming. Some of the things I want to talk about, the label, for instance. The most important part when you're going to order one, this is a fan motor, not a blower motor. A blower motor you can tell because it has holes in it. You wouldn't put one on the outdoor unit because the weather would get inside it real easy because there's a bunch of holes around it. And when I get one, I'll show you what I'm talking about. So there's a difference between a fan motor and a blower motor. A fan motor and the blower motor, they do have RPMs. The labeling and stuff are almost the same, except that usually the blower motor has to be stronger because it's usually handling what they call a blade system that's called a squirrel cage blade, all right? A fan motor is just like it says, like a fan in your house, like if you got a little box fan. It's just got a blade with a pitch, all right? It has a load, but not as much as a squirrel cage. Squirrel cage blade type system has more air volume, more CFMs, as you might, cubic feet per minute, than a fan blade, all right? But I took the bolts apart off. Now it's all the bolts off. Now here's the trick of it. This is an old motor. And like I said, I normally would have my rubber mallet, but I'm not going to try to hit it too hard because I can damage it. So all I'm doing is, if you ever had trouble taking the cap off and you just tap around the edges, try to get it to break free, loosen up, that's what I'm doing. But not trying to hit too hard. If you notice, there's starting to be some separation right here. And sometimes I can get me a screwdriver in there and give it a tap. Like I said, we're not trying to manhandle it. See, it's coming loose. Now it's got enough where I can go around and start wedging myself around it. Alright? So, pops off. Now I can take the back side off. And if you'll notice, inside here is where the bearing. These are sleeve bearings, not ball bearings. There's two types of motors. You got sleeve bearing motors and you got ball bearing motors. This is sleeve bearing. Lubrication is very important for this. Again, we're going to do the other side, and I think we've already loosened it up quite a bit. If you notice, it doesn't take much to get this off. All it is those four little long threaded nuts and bolts there that is actually holding this together. Now, there's a difference on the inside about the windings and stuff that causes the motor rotation. Okay, so now we have it out. Here's the motor. A lot of times this gets corroded inside here. I wonder if anyone that's watching this video knows what this is and what the parts are of this motor. Well, in this video we're just talking about servicing it. A lot of times you would not do this. When you're servicing it, you would not take the bell housings off of the motor. If you notice, the shaft is attached to the top part where the blade is, the fan blade is connected to. Alright? You can take it out, but you got to pull it. Alright? It's really hard to pull, but you can pull it off because it's dirty. Alright? And normally, this would stay sitting inside here, but this is where, if you'll notice, there's no electrical mechanical parts for this between this and the electrical wiring, if you notice. So that spins, but what causes it to spin? A magnetic field. It's using a push-pull method that causes this motor to spin. North, south, north, south, north, north, south, south, to push and pull, you know, really quickly, all right? I can see some obvious damage from water because it's really corroded and rusted on both the inside and all. And if you notice, it's really hard to turn it inside there, all right? And look at my hands, it's all dirty and nasty. So this motor has been in water. A lot of times people put their condenser units underneath the eave of a house and water runs off instead of putting any gutters underneath it underneath the eave to prevent the water from rushing on it. It's designed to handle water like rain on it, but not gushes of water just pouring on it like if you were taking a giant cup and pouring on the unit. It's not designed for that. It's designed to just handle regular rain, not a monsoon pouring over the top of it, all right? Normally a burnout motor, you would find a black spot in here, but this one wasn't a burnout motor. So if it was a short, it would be tripping, but this one tried to work, but it couldn't rotate, and that's because of the corrosion in the dirt. And here's where the corrosion of the problem was, is this wasn't lubricated, all right? All right, again, back at the motor. Also, you may want to use gloves. I usually use my bare hands, but it takes a while to get this stuff off of here. All right, this is what it looks like on the inside. Matter of fact, fire ants like to get in here and cause destruction. Not because they eat away or anything. They just die and get damaged, and they build up in here, and it causes friction and causes it hard to turn. The normal thing is you get rusting on this metal inside here and on this here where it doesn't get a good magnetic field. It interferes with it, and then you don't have good rotations on the sleeves here. So that's where you get the lockup a lot of times. And here's the biggest problem right here. If you can see it, it's corroded, it's nasty, it's got cake buildup right here, and it's just really causes a lot of resistance, which causes the amps to go up, causing the motor to trip on overload, which is built inside these windings right here, all right? And so basically, like on the components here, again, when you're servicing it, you would not take it this much apart, but I wanted you to see the inside components. This is the rotor. Rotates, rotor, that's the best way to remember it. The rotor is the one that rotates, it's not stationary. This is the device that with the creation of a magnetic field, induced magnetic field, and inside here, matter of fact, I don't know if you can see it. It's not a good one to look at because it's corroded, but there's little different slices on here, which is used like wraps of copper wire, but instead of being wire, which wouldn't work very well to rotate inside here, so it uses flat solid metal type that are put together and separated and put together to create a magnetic field. I mean the coil type method, all right? But again, this is the rotor that rotates, rotor. The stator is where it's stationary. This is what the rotor sits inside of and spins. Okay? These are the windings. And on this particular motor, there's 3 wires. The newer motors has 4 wires for a condensing fan motor. You have the 2 hots, which is a 120, 120, which is different phases. And then the capacitor wire. Okay? And if you'll look, if you can see the label here, it doesn't have it on here. Sometimes the label has a diagram, but this one does not. But if you can see, if we can focus in on it, I'm going to point out the most important items in a motor. Okay? Horsepower, that's the strength of the motor. The model number. The amps is important when you're servicing it because you need to know, is it under the amp rating and within the range of amps. The RPMs, which this is 1075. And sometimes on these motors it gives you the capacitor size for this motor. But this is an older style one, so it's got limited information. But the newer ones even have a wire diagram, has all this information including the capacitor size. But again, when you're ordering a new one, you need to know the model number, the horsepower, probably the amps, if it's single phase or three phase, and is it 1070, the speed, the rotation speed of the motor, which is rotations per minute, which is 1075 for this one. Okay, and again, that's the label. You can barely see it, but the thermal overload is right there, and they usually build them inside the windings, and you can't take this off. Matter of fact, you see the copper wire, and it looks like it's just plain old bare wire, but it's not. It's coated with a type of lacquer material that keeps it from touching each other, which would create a short. Matter of fact, when a motor shorts out, that lacquer melts off, and the copper and copper touches together, and it's just like having taking a wire from the neutral to the hot directly, and it just pops. Okay, not a good thing. Matter of fact, you'll know it because it'll trip the breaker immediately when if you try to turn it on, or if a breaker's tripping. That's usually what causes it, is this lacquer stuff is melted down. All right. You probably won't see it, but you can check it with a meter, and if you get no resistance, it's melted together. All right. Hope you enjoyed taking apart the motor and seeing what it looks like on the inside. Again, stator, stationary, rotor, rotates, and bell housings. That's an AC motor. If you notice, there's no permanent magnet in this one. This is not a DC motor. This is an AC motor, alternating current. The magnetic field is induced by the AC going negative and positive 60 times per second, changing 120 times per second. All right. Hope you enjoyed it. If you take care of the motor, they'll last for a long time, but if you leave it to its own devices, no. When you first get a new unit, you can probably go about 2 years. After that, you need to have it serviced every year. You don't have to take the motor completely apart like this. Only when the amps start to rise a little bit. When you service a unit, you'll check the amps. If it's slightly higher than it has in the past, it may be time to start doing that to make it last a little bit longer. But that's usually because it just needs some more lubrication. All right. Hope you enjoyed this.